able to do a process called completing the square. So for completing the square, the whole goal of this, here are the steps listed out. We're going to go through those in just a second. But let's understand why we would be completing the square. What's the purpose? So the purpose of completing the square, okay, is to convert our quadratic equations from standard form to vertex form. Okay, so now what is standard form versus vertex form? Do you remember? So standard form is what we were looking at last week when we were factoring trinomials. So standard form is when you have ax squared plus bx plus c. Okay, that should look pretty familiar. Your trinomial with your squared term first, and then an x term, and then a constant. Okay, so that's standard form for a quadratic. Vertex form is what we started looking at this week when we were looking at the graphs and the transformation rules. So vertex form is when you have a factored out, and then you have x minus h squared plus k. So where hk is the vertex. That's why it's called vertex form, because you can see the vertex. So we need to be able to convert the equations, rewrite the equations from standard form to vertex form. So that's the whole point of this completing the square. Okay, it's called completing the square because what we're doing is we're creating a perfect square trinomial that will factor to this x minus h squared, this binomial squared. Okay, so to do that, today we're going to focus on when a is 1. So a is an understood 1. There's not a coefficient out here that we have to worry about. Okay, so it's going to be pretty straightforward for this process. And then tomorrow we'll look at, okay, what's the extra work I have to do if there's an a value other than 1. Okay, so you can see in this example that they're walking you through on the steps that you want your equation. If there is no equal sign, just add an equal sign and a 0. Set it equal to 0. Okay, if there's already an equal sign, great. You don't need to add one. And you want to get your constant to the right side and your variable terms, so your x squared and your x term, on the left side. Okay, so they had x squared plus 4x plus 3 equals 0. So they subtracted 3 from both sides. So now you've got your variable terms on the left and, bless you, your constant term on the right. So that's the first step. Okay, variable terms to the left, constant to the right. If you want to write that here, if you like that wording better, add that here. Variable terms on left, constant on right. Okay, once we have that, what we are looking to do with this is we still want to create a perfect square trinomial. Okay, so you see how they just wrote the two variable terms and then equals the constant. Okay, what I'm going to be doing is I'm going to write my variable terms, and then I'm going to put a plus blank, and then I'm going to have my constant on the other side, and I'm going to put a plus blank. Okay, I add these plus blank on both sides. because I'm trying to, again, create a perfect square trinomial on the left side here. Okay, and I've got to figure out what constant, what number would go in this blank to make this a perfect square trinomial. Okay, so the process of getting that number, that's step 4, okay, and it is to take your B value, bless you, let's highlight B. Your B value is the coefficient in front of X here, okay, so you take your B value and you divide it by 2 and square it. Okay, so we take the middle term, divide it by 2, and then we square it. Really like the way that this is worded because it says to divide it by 2 and then it says square B. You're not squaring B, you're squaring B divided by 2. So I'm going to correct that. Okay, so you take B, divide it by 2, and then square it. Divide by 2, then square. That's what goes in the blank. Okay, so what you get when you do B divided by 2 squared, I don't actually see that all written together somewhere. So step 4 and 5 together is B divided by 2 squared. That value that you get is what you're going to put in these blanks. Okay, those 2 blanks. And I have to add that blank to both sides because yes, I'm trying to create this perfect square trinomial on the left, but what you do to one side, you do to the other. That's supposed to be a plus. I accidentally deleted that. Okay, so you have to do it to both the left and right side. Okay, and to figure out what that number is, we're going to do B divided by 2 squared. Now, after we find out what that term should be, here is where we add it to both sides of the equation. That's what I just highlighted up here. I add it to both sides of the equation. Okay, and that completes the square. You can see it makes this a perfect square trinomial, meaning that this right here will factor into this binomial squared. Now, what goes in that binomial squared okay, what goes in here with the x is half of b. Okay, it's this b divided by 2 from, oh, that's not what I wanted to highlight. I want to highlight the 2. Come on, there we go. This b divided by 2 before we squared it. Okay, just b divided by 2. That's what goes here. Okay, with the x. It keeps the same sign and everything. Okay, so you just have to be able to identify that b divided by 2. Okay, so the inside part of this, that part right there. And then when we square it, all of it is what goes in the blank. But just the inside part, just the b divided by 2 part is what goes in this blank here. Okay, so I know just breaking it down like this, it kind of sounds confusing. So it's going to make more sense as we work some examples. Okay, so let's jump into the process. Okay, so step 1, I'm going to get the constant to the right side. So this is 8. So I'm going to subtract 8 from both sides. And this is where I'm going to now put my plus blank. And on the right side, that 0 minus 8 is just negative 8. And then I put my plus blank. Okay, so I move the constant to the other side, but now I have to figure out what is going to go in this blank. So it is b divided by 2 squared. Okay, that's what's going to go in the blank. So what is the B value here? Just the 6. X is not A, B, and C are just numbers. X is the variable. Okay, so B is 6. So I'm just going to take 6 divided by 2, which is 3. And then I'm going to square it, which is 9. So 9 is what I add to both sides. Okay, so what I have created on the left side here is this perfect square trinomial. So this trinomial will factor. Actually, I'm going to break it down. Before I write it as the binomial squared, let me explain why it does this. Okay, remember the X method we were doing last week? We said you put the A times C on top, so that would be 9, and the B on bottom. And we're like, what multiplies to the top but adds to the bottom? What two numbers multiplied to 9 but add to 6? 3. Okay, so they end up being the same number, positive 3, positive 3. That's why when we say you factor it, it comes out the same, x plus 3, x plus 3. So instead of writing it that way, isn't that the exact same thing multiplied by itself? So that's why we just write it as x plus 3 squared. Okay, so we took this perfect square trinomial and it became this binomial squared. Okay, and you don't have to you don't have to do this X method every time. I am telling you what goes in that blank is half of B. It's this B divided by 2, which is the 3. And you can see it was just a 3 that went there. So far, so good? Okay, well, let's look at the right side, and we'll try this again with another one. Go through it again. How does the right side simplify? We have negative 8 plus 9. Just a 1. Okay, so we have gone from standard form to almost vertex form. Vertex form has it all on one side, right? Okay, so how would I move that 1 back to the other side? Yeah, I'd subtract that 1 back over. Okay, so if I subtract that 1 back over, this is x plus 3 squared minus 1. And you can see your A, H, and K. If you want to write y equals, that doesn't hurt anything. So there's your quadratic in vertex form. Again, I broke this down here in the middle, doing the X box here and showing that it's the same binomial twice. Okay, you do not have to show this every time. I'm just explaining why it always breaks down this way. Okay, we found 9 so that this would factor to a single binomial squared. Same binomial twice. That's the whole point of this process. Okay, so let's try it here in number 2. So first I'm going to move the constant to the other side. Okay, so this is going to be x squared minus 12x. And I'm going to figure out what is going to go there to make that a perfect square trinomial. Now the 28 is now negative 28. And I've got to keep it balanced. What I do to one side, I do to the other. So if I'm adding a number here, I've got to add a number here. Same number. Now I'm going to figure out, okay, what's going in that blank? It's b, which is negative 12, divided by 2 squared. What's negative 12 divided by 2? Negative 6. And negative 6 squared is, yeah, it's positive 36. When we square a negative, it comes out positive. This is always going to be a plus. We're always adding a number to both sides, but the sign matters for when we go to plug this in beneath here. And actually, I did it in blue on the other one. I'm going to change this real fast. I just want to keep my color coding the same for all the problems. Sorry. Okay, so I did -12 divided by 2, got -6, squared it, and got the 36. Okay, but the negative matters because this number here, remember, is what's going to go in my binomial squared. It's going to be x minus 6. The sign matters right there. Okay, so that trinomial becomes x minus 6 squared. You want to highlight, it's the b divided by 2 that comes here. Okay, and then what about on the right side? What's -28 plus 36? 8. Because the 36 is positive, the -28. So 36 minus 28. Okay, now if I want this written in vertex form, I've got to move that 8 back over. So this would become x minus 6 squared minus 8. Once we have the equation in vertex form, I could tell you the vertex, right? What's the vertex of this equation? Of this quadratic? +6, -8. Remember, the h is the opposite of the sign that you see here. So 6, -8 would be the vertex. A is an understood 1, so it's opening up. It's not stretched or compressed. It's just shifted right 6, down 8. Okay, that's why we need to be able to go from standard to vertex form so that we can identify the vertex and what transformations taken place, all that stuff we were working on the past couple days. It's got to be in vertex form for us to be able to do that. Now let's try another one. Flip over to the back. Okay, we're dealing with p's instead of x's. It doesn't change anything though. So I'm going to move my constant to the other side and do my plus blank on both sides. Now what do how do I figure out what goes in that blank? What goes in this blank? What did we say? B divided by 2 squared. B divided by 2 squared. B divided by 2 squared. You've got to learn that. B divided by 2 squared. That's how I'm going to figure out what goes in that blank. What is my B value in this one? 14. I'm going to do 14 divided by 2 squared. So that's 7 squared is 49. So 49 goes in the blanks. So I've created this perfect square trinomial on the left that's going to factor to P what? What's going to go here? Yeah, it's the half of B. It's before we squared it. It's just the B over 2. Okay, so it's +7, so +7. Okay, and then on the right side, I've got -38 and +49. So that is 11. So then if I want to write this as a quadratic equation in vertex form, that is P plus 7 squared, and then that 11 would have to be subtracted over. Okay, let's do it again. Move the 19. I'm going to have my plus blank. I got to figure out what's going to make this a perfect square trinomial. Okay, the 19 on the other side becomes negative. What is my B value this time? What is the B value? -6. So go ahead and try that. Y'all see if y'all can do that while I get the phone. Sure. Do you have a packet? Then no. Sure. Okay, no problem. Bye. Mel, when you leave, just walk there the front office. This like a data specialist, I think. Let's go to the front office when the bell rings. Okay, sorry about that. So we said B was -6. We're dividing by 2 and squaring it. So -6 divided by 2 is -3. Squared is +9. So 9 is what should go in your blanks. Okay, if you want to keep highlighting or color coding, we can do that. And then we do our factoring that perfect square trinomial. It's going to become V what? What's in there with the V? -3 minus 3. Good. It's the B divided by 2. So -3. And on the right side, -19 plus 9. So that's -10. Oops, get out of here. So if I want this in vertex form, I would have to move the 10 over by adding. So it would be V minus 3 squared plus 10. What would be the vertex here? You're asked what's the vertex of this quadratic. What is it? 310. That's right. +3, +10. Okay, if you can't answer what the vertex is, once we get them in vertex form, you need to be sure you're going back over the previous lesson that we spent 2 days on, going over those transformation rules and finding key features of the graphs and all of that. Now you've got to be able to understand HK is your vertex. When I say HK, I'm talking about this up here. Remember, it's the opposite of the sign of the number in here with the X, and then the number added on the outside. So HK is your vertex. That's why it's called vertex form, because we can easily spot the vertex. Or what should be easily. All right. Sure, everybody's got this. Stop me if you're confused on something. These are slightly different. This one is not set equal to 0, but I still need to move that 26 to the other side. Okay, but there's already a number on the other side. So we do have to combine those first. I'm going to do my plus blank. And then on this side, what is 8 minus 26? -18, then my plus blank. Okay, so this just had a little extra step there of having to combine those like terms when you move your constant. Okay, because it didn't start set equal to 0 yet. Okay, so we've got to do a little extra math there at the beginning, but now it's the same. So we take our B value, -10, divide by 2, and square it. So -5 squared is 25. So 25 is what goes in our blanks. Now that perfect square trinomial is going to factor into a binomial squared. What's the binomial? M what? -5. Good. If you're confused on where this -5 came from, it was the B divided by 2. B divided by 2 is what goes in this blank. Okay, what went in this blank was once we squared it. Okay, we did b divided by 2. Once we squared it, then we got 25, and that's what went in that top blank. All right, so if I wanted, on the right side, we need to condense here or simplify. Negative 18 plus 25, what is that? Seven. M minus 5 squared, and then I would have to subtract the 7 to be over on the same, excuse me, on the same side. What's the vertex? 5, negative 7. Very good. All right, on this last one, this is not set equal to 0. It's not even got the variables on the same side. Okay, so instead of moving the constant to the right, I'm going to have to move the 8n, that variable term, to the left. Okay, so that's going to be subtracted over an n squared minus 8n. Okay, and then I'll do my plus blank. So then the only thing left over here is going to be that negative 17, and then I do my plus blank. So I moved the variables to one side and kept the constant on the other. Yeah. Okay, now to figure out what goes in that blank, I am taking my b value, which is negative 8, dividing by 2 and squaring it. So that perfect square trinomial we just created will factor into what squared? What goes in here with the n? Minus 4. And on the right side, negative 17 plus 16 is negative 1. So when I go to write this in vertex form, I have to add the 1 over. Need the highlighting, add the highlighting. The whole thing squared, b divided by 2 squared is what went in that blank. Just the b divided by 2 is what went here. All right. So this is the completing the square process when a is 1. We didn't have to worry about any coefficient in front of our squared variable. Okay. So this is how we complete the square when a is 1. We're going to look what happens when a is not 1 tomorrow. But for now, you should practice when a is 1. So there is a practice assignment for you in Delta Math. Oh, got logged out. Let me log back in. So you should definitely see today's assignment. You may see yesterday's if you have not finished it. So this assignment from the 15th and 16th, we spent a couple days talking about graphs of quadratics. If you have not finished that practice, it's due Sunday. If you would like to finish it first, you can. If you don't see it here, you finished it. Good job. Okay, and then here's today's assignment. It is due Monday. Okay, it's completing the square when a is 1. And you'll notice it's just one type of question, and I just need you to get 5 of them right. Okay, so it's a short and sweet assignment. If you want to go ahead and knock that one out, and then you can go back and finish the graphing one later, that's up to you. Okay, but you've got the deadlines listed there next to both of those. You could possibly have 2 assignments available for late credit under the past due tab, these factoring ones from last week that were due this week. So they're both still at 75% credit. One of them, bless you, the day 3 factoring by grouping, that's only at 75% credit through tonight's. Okay, so get that taken care of. If you don't see anything here with late credit available, that means you finished these already, so you're good to go. All right, so you have the rest of class to practice. You can work on whichever of those practice you feel most pertinent. Okay, but pay attention to all those deadlines and don't let those go past. I want to emphasize this is a new 9 weeks this week. Okay, so when we go back, we look at this calendar. We started a new 9 weeks. I'm working on updating the calendar, but last 9 weeks, all of that from last 9 weeks is done. It's frozen. That grade is finalized. You can't change it. Okay, but you don't have to build off of it for the new 9 weeks. It's not like if you had a 60 that 60 is still carrying and you're still trying to get that 60 up. You start fresh the new 9 weeks. You don't have anything in the grade book right now. I'm going to go put those Delta Maths that are under the past due tab. I'm going to put those in the grade book. Okay. But you're not having to build off of if last 9 weeks, if we go to those past previous calendars, if we go to Q1, all that work from Q1, you're not having to work back if you kind of fell off there at the end or let stuff zeros snowball and late work and all that and didn't do test corrections, whatever the case. Okay, you can come back from that because you have a clean slate for the new 9 weeks. Okay, and then the 9 weeks will average together for a semester average. And then next semester, you can do the same thing, keep up doing better work habits, and that'll all average together for a final year-long average. Everybody can get their year-long average to passing, even if you failed that first 9 weeks. Please don't give up. Nobody is a lost cause. If yours was like a 20 or a 30 because you just quit doing anything, guess what? I bumped your grade up to where it's possible you can still pass because I don't want you to feel like there's no point. Okay, I want you to keep working, change some of those work habits. You can come back from it because I bumped those failing grades up high enough to where it's possible that they will average to passing. Okay, but you do have to change some of your work habits. You do need to make sure you're completing your assignments. Don't let those zeros stack up. So if you have these under the past due tab, go get them done. Okay, 75% credit still available. You can still get passing grades on those. Okay, you want to get as high of a grade as possible you can this 9 weeks to average with last 9 weeks. Okay, take advantage of test corrections. Even if you pass the test, you can correct what you missed for points back. Okay, a lot of people didn't take advantage of test corrections. I don't understand it. Okay, I'm giving you points on your test grades for just fixing your mistakes. Okay, sign up to come to Cat Tracks to do that when needed. Sign up to come to Cat Tracks just to get your work done and ask questions if you're struggling. Okay, do everything you can to do a little bit better this 9 weeks. Oh, and one last thing that really was a kicker for a lot of people was the review. A lot of people weren't doing reviews. The review is not only a grade in and of itself, it helps you prepare for the test. The reviews were inaware, just like the test is. It's showing you the formatting of the questions, the style of the questions. Do the review. You will be better prepared for the test and you'll get a grade for it and not a 0. Okay, so do the reviews before the test. And remember, I open them up. You want to do it a week ahead, get it done, and then I'll reopen it and you can fix your mistakes. Okay, I'll reopen those reviews as many times as you want to fix your mistakes leading up to that test. Okay, so take advantage of all these scoring opportunities to get those grades up and be better prepared for tests.